to Pharero Academy, the learning channel for physics and mathematics. Please subscribe our channel, like it and share it. This is the find an equation when its roots are related to a given equation. I have already done this topic in previous video, but it was a substitution. Now I will be doing the special substitution method and no substitution method. In previous video, this equation was same. If alpha, beta, gamma, the roots of the equation x cubed minus 6x squared plus 11x minus 6 is equal to 0. Find an equation whose roots are alpha, beta, gamma and alpha, gamma for this question. But in previous question, it was alpha square, beta square and gamma square. So for alpha square, beta square, gamma square, we use the substitution. We say x is equal to alpha or x is equal to beta. So alpha and y is for an equation y is equal to alpha square, so y is equal to x worked. But now let us see in this equation, if I use the ordinary substitution method, what happens? See, I will say that since alpha, beta, gamma are the roots of this equation. So I can say x is equal to alpha, x is equal to beta, x is equal to gamma. Let y is equal to alpha beta, y is equal to beta gamma and y is equal to alpha gamma be the roots of required equation. So I can say y is equal to alpha is x, beta is, so y will be x square. Here y will be x square. Here y will be x square. But if I put y is equal to x square, I will get the equation whose roots are alpha square, beta square, gamma square, not this root. So I will go another, this is special method, substitution method fails. So I will use the special substitution method. Again, now think like this one. I can say alpha, beta. Okay, now alpha, beta, I'll first give you the values of this one is better. Can I say now, if alpha, beta, gamma are the roots of, this equation, can I say alpha plus beta plus gamma is always equal to minus 6, so 6 alpha, beta plus alpha, gamma plus beta, gamma is equal to what? 11, and alpha, beta, gamma is what is minus 6. So if I take this, okay, let y is equal to alpha, beta, y is equal to alpha, gamma and y is equal to beta, gamma. Okay, now I am taking this one. Can I say alpha, beta, gamma is 6? So can I say alpha, beta is 6 upon gamma? So can I say alpha, beta is just y is equal to 6 upon x for this one. Again, I am taking alpha, beta, gamma is 6. So can I say beta, gamma is 6 upon alpha? So can I say y is equal to 6 upon x? Again, I am taking alpha, beta, gamma is equal to 6. Can I say alpha, gamma is equal to 6 upon beta? So can I say y is equal to 6 upon x? So if I substitute, this is a special substitution. So I will substitute here y is equal to 6 upon x or x is equal to what? 6 upon y in given equation. This is the special substitution and I will get the answer. X is equal to 6 upon y. Now original equation is, actually I can write the original equation is x cubed minus 6x squared plus 11x minus 6 is equal to 0. The original equation. Now I'll put x cubed, means it is what? 6 upon y whole cubed minus 6. This 6 upon y whole square plus 11, 6 upon y minus 6 is equal to 0. So this will be 216 upon y cubed. This is 6 square 36. This will be minus 216 upon y square plus 66 upon y minus 6 is equal to 1. Multiplying all the terms of y cubed, multiplying all all the terms by y cubed. If you multiply all the terms by y cubed, this becomes 216 minus this one 216y plus this 66y squared minus 6y cubed is equal to 0. So I will take this one now. So 216 minus 216, this one I can say minus 6y cubed and plus 66y squared minus 216y plus 216 is equal to 0. Take minus 6 as common. If you take minus 6 as common, this becomes y squared and minus this, sorry, y cubed. This is y cubed minus this will be 11y squared and minus this will be 36y and plus 36 is equal to 0. I can write this y cubed minus 11y squared minus 36y, minus 6 is common, so this is plus 36, sorry, plus 36y, this minus plus 36y and sorry, I have done here the mistakes. I am writing it again. So it is minus 6 as common. If I take minus 6 as common, this becomes y cubed minus 11y squared plus 36y minus 36 is equal to 0. So this should be the answer. This is the answer by this one. Now I'll take it in another method. Another method is not the substitution. I will not use substitution here. For the general cubic equation, I can take ax cubed in terms of y. Suppose ay cubed plus by squared plus cy plus d is equal to 0. If I divide by all, this becomes if I divide by ay cubed plus this is b upon ay squared plus c upon ay plus d upon a is equal to 0. If I can write this y cubed, this one I use plus minus in this way. So minus, I can write minus b upon ay squared, and this should become plus c upon ay and minus d upon a is equal to 0. Now I will say, suppose if I am able to find the value of minus b upon a, c upon a, and minus d upon a, I'll put this equation and get the things. Now given equation is, let us see, the given equation is x cubed minus 6x squared and plus 11x minus 6 is equal to 0. Its roots are alpha, beta, gamma. So alpha plus beta plus gamma must be minus 6. Alpha beta plus alpha gamma plus beta gamma is 11 and alpha beta gamma is 6. Now I have to find the value of minus b over a for this one equation. So minus b over a will be equal to, if alpha, first I should write this way, let alpha beta, alpha gamma and beta gamma be the roots of required equation. If alpha, this one, so can I say minus b over a will be alpha beta plus alpha gamma plus beta gamma. So minus b over a we have already found from given equation alpha plus beta, this is 11. So minus b over a is 11. Now let us find c over a. C over a will be product of 2 and their sum. So it will be alpha beta into alpha gamma plus alpha beta into beta gamma plus alpha gamma into beta gamma. This should become, this is alpha square beta gamma plus alpha beta square gamma plus alpha beta gamma square. I can take alpha beta gamma as constant, so this is alpha plus beta plus gamma. I can put these values. Alpha beta gamma is 6, I have written here 6, and alpha plus beta plus gamma is 6 also, so this becomes 36. Now let us see what is minus d over a. This was minus b over a, now minus d over a. Minus d over a must be alpha product, alpha beta, alpha gamma and beta gamma. So it is just alpha square, beta square, gamma square. Or I can write alpha beta gamma whole square. So this is 6 whole square. This is now the 6 whole square, or this is 36. Now equation is y cubed minus b upon a y square plus c upon a y minus d upon a is equal to 0. Put the values. Y cubed minus, what is minus b over a? Minus b over a is 11. So 11 y square plus what is c over a? C over a is 36. 36y minus d over a is what? Minus d over a is 36 is equal to 0. This method is always valid for all the equations. Y cubed, if substitution method fails, we can use this one. Although that's not in your course, for further maths Cambridge level, 11 y square plus 36y minus 36 is equal to 0, and this is the same equation as we obtained in the special substitution method. You can see the same equation exact. So we can solve this equation for a quadratic equation is given. Suppose ax square, if for quadratic equation a is y square plus by plus c is equal to 0. For quadratic equation this must be y square plus b upon ay plus c upon a is equal to 0. I can write y square minus b upon ay and plus c upon a is equal to, for quadratic. For cubic I have done here, but for a quadratic equation is given. Suppose ax it is general ay power 4 plus by cubed plus cy square plus dy plus e is equal to 0. So I can always write y power 4 minus b upon ay cubed plus c upon ay square minus d upon ay and plus e upon a is equal to 0, where minus b upon a will be sum of the alpha beta gamma product and whatever you can get. So minus b upon a you can get, c upon a you can get, and minus from required condition or given conditions, then you can solve these equations. Thank you very much.